In this one, I'm going to solve this guy here. So let's do let B, letter I, 3 I's, right? Now the total energy of the thing is going to be the kinetic plus the potential energy, right? Okay, the potential energy we actually figured out of the Earth around the orbit. We figured that out in B2I, right? We've got a potential energy, but how to figure out the kinetic energy is difficult, right? So let's think about this, right? We know that the potential, the gravitational potential at the potential V, let's call it this, the VG, right, at the surface of the sun is minus G m over r, right? And at the surface of the sun, this is negative 1.9 times 10 to the 11th, right, is equal to negative 6.67 e minus 11 times the mass of the sun, and then they give us the radius, right? So 7 e8, right? So we ought to be able to figure that out, right? We ought to be able to figure out the mass of the sun. So the mass of the sun is the minus signs go away, right? So 1.9 E11 times 7 E8 divided by 6.67 E minus 11. This is roughly 2 times 10 to the 30th, right? Equals the mass of the sun, right? So now that you know the cat's out of the bag, right? Okay, we now can find the potential energy is going to be our negative 5.32 times 10 to the 30th, right? To the 33rd, sorry. Okay. But the kinetic energy is going to be something else, right? So we got to figure that out. How can we figure that out? Well, we know the orbital velocity, and this is in the data packet. This is a V, not a potential, but a velocity, okay, is equal to square root of gm over r, right? We know the mass, we know that, so we can figure that out, right? The kinetic energy is 1/2 mv squared, and we know the mass, this would be the Earth moving, right, at some velocity. This would be the mass of the sun, this is the mass of the Earth, right? Okay, so that's going to be 1/2 times the mass of the Earth, right, times this thing squared is just take away the radical, right? So g times mass of the sun over r, right? Okay, so we can figure this out, right? So this is this is 6.0 times 10 to the 24th. This is 1.99 times 10 to the 30th, right? And then our radius is 1.5 times 10 to the 11th. Yeah? All right, so we're doing this. We're going 0.5 times 6e24, right? Times 6.67 e minus 11 times the number I just got on my calculator, which is the mass of the sun, right? Divided by r, which is 1.5 e11. Okay. And I get 2.66, positive 2.66 times 10 to the 30th. So kinetic energies are positive, right? So remember, our potentials, all gravitational potentials are negative. This guy is 2.66 times 10 to the 33rd, which is, that is the correct answer, right? Okay. And so now I'm going to go positive 2.66 E33, right? Okay. And then we combine that, right? Plus negative 5.32 E33. And I get, whoops. If I go this guy, minus 5.32 E33. I get the correct answer, right, for the total energy. So that is actually one way to do that, right? The other way to do this, I mean, does this look familiar, right? This is GMM over 2R, right? The other way to do this, I'm going to erase stuff here, right, is to do this, right? Our total energy is kinetic energy plus potential energy, right? The kinetic energy ends up being is 1/2 mv squared. I'm just going to cheat and use the formula in the data packet for this. So this is the mass of the Earth, right? The velocity is square root of g mass of the sun over r, right? If we plug that in, we get 1/2 mass of the Earth, g mass of the sun over r. Ultimately, we end up with g mass of the Earth, mass of the sun over 2r is our kinetic energy. If you recall, the potential energy, gravitational potential energy is, and this is on page 11. Is it on page 11? On page 11, I want to say. On page 11, yeah, there it is. Okay, the gravitational potential is minus GMM over r. Mass of the Earth, mass of the sun over r. Now, I hope you realize that the kinetic energy is negative 1/2 of the potential energy. Do you see that? This is 1/2 of this if you ignore the minus sign, right? So the potential energy is negative twice the kinetic. And that must always be true, which is interesting, right? If it's in a circular orbit, which is kind of an interesting thing. It's sort of an interesting thing to understand, right? And so basically if we go, the total energy is positive, how to write this, right? Positive 1/2 the potential. If we take the potential as a positive value, right? Minus the potential, right? Okay, ends up being minus 1/2 of the potential energy. I don't know, yeah. Anyway, it's a negative number, okay? The potential energy is bigger than the kinetic energy and it's negative, so therefore we end up with a negative number. Anyway, that's how I originally solved it, but then I realized that's kind of weird. But, you know, it's all weird. It's an IB test. Happy hunting. Sorry about that.